Hello, my name is Kalimullah Brohi, and my project is reference guided pseudo label generation for medical image semantic segmentation. And the problem statement is that the acquiring medical image data is very difficult in the first place because of the privacy issues and other issues related to it, like patient's privacy and obtaining their data in the first place. Uh, and image segmentation for the data is even harder because you have to annotate each pixel in the image for semantic image classification, for semantic image task. And the solution that this paper presents is of using reference guiding for pseudo labeling of the images for medical imaging tasks. And it also uses icon consistency where weak and strong augmented images are generated for the same unlabeled image, and they're used to guide the model towards accurate pseudo labeling. The dataset that I've used in this project is GSRT dataset. The original dataset was not available, so I used a subset of it. The link is given in the project report. So it had the original image along with the actual mask. The ground truth mask represents the lungs and the various other parts of the body. So the project used UNet for the semantic segmentation of the image, and this is an example of what the original image looked like and what was the actual mask and what was the predicted mask for the image from the enabled set. And then the image was weakly augmented by adjusting the brightness. You can see the results of the model on the weak augmented image. And also the image was strongly augmented by using affine transformation and rotating the image a bit, and also using different color complexes. So the model also performed very well on the strongly augmented image as well. So this is how the cycle consistency was obtained, and the results with reference guiding look like this, where the original ground truth is there and the original image is there, and the pseudo label which is assigned by using various number of neighbors like 5, 7, 9, etc. And this was obtained by finding the distance between the features of the unlabeled image and those of the reference guided pool, and they were compared. The distance was compared between them, and then one having the lowest distance was obtained. So I also performed two ablations. One ablation was removing the reference guiding for pseudo labeling, and the another was to test any other model other than UNet. So I used DeepLab v3 instead of UNet. So this was the result of using the pseudo label as it is, the output of the model. And you can see this is very noisy and this is not that good. So this proves that the authors did a very wise, made a decision about using reference guiding instead of using the modern's output as it is as the pseudo label. And another ablation that I did was using DeepLab v3. So you can see the predicted mask is much worse than the actual mask, and also as compared to the UNet output. So this also proves how good the authors were about making the choice of using the model for semantic image segmentation.